All right, in this problem, you're kicking a ball up at an angle, upward, off the top of a building, and that we eventually want to find the height of the building. So what do we know? We know that we kick it upward with a VIY equal to 17 sine of 49, which is 4.18 meters per second. We also know that this value is going to change by negative 9.8 meters per second every second the ball is in the air. Vx, on the other hand, is 17 cosine of 49, or 11.2 meters per second, and that is never going to change because there's no forces acting on it. And we know that it travels 67 meters from the edge of the building. Now, we want to find the height of the building, so how are we going to go about doing that? Well, remember that the velocity that determines how long it's in the air and determines how high it goes and all that kind of thing is the VIY. We know that we launch it upwards at 4.18 meters per second. At the top, that 4.18 meters per second is 0. It's still moving, but it's only moving forward at 11.2 meters per second. When we get to an identical point, a symmetrical point on the trajectory that is exactly the same height that the ball was launched at, it is now traveling downward at negative 4.818 meters per second and forward again at positive 11.2 meters per second. And now from that point it's going to keep falling, and it's going to fall the height of the building, delta y. Now, in order to find that height, we're going to have to use a kinematics equation. We already know we're going to plug in 4.18 meters per second, but we don't know what else we're going to put in there, right? Well, we know gravity is negative 9.8 meters per second, so we know that we're going to plug in a negative 9.8 for any accelerations. But we don't have enough information to find delta y yet. We need to have something else, and the easiest thing is the time. So we know that it travels 67 meters forward, and we know that it's traveling at 11.2 meters per second. That means that I can use the range formula, which is Vx times total time equals range. 67 equals Vx, which is 11.2 times time. If I rearrange that, I get somewhere around 6.0 seconds. Now, I've got the time, I've got the initial upward velocity, and I've got gravity, which is negative 9.8. So I'm going to use my delta y formula, which is delta y equals 1/2 gt squared plus VIY times t. I plug in my numbers for g, negative 9.8, 6 for time, and a positive 4.18 times 6.00 seconds, because I initially put it up at a positive speed. And if I do my algebra correctly, I should get the answer.